the heat engines. Heat engine is a device which converts heat energy to work. It is a device which converts heat energy into work through cyclic process. Through a cyclic process. This is done by the system. This is done by the system. Here we are called system as the working substance. Here we are defining the system as working substance. Working substance. Okay. Then look at the figure. There are mainly three parts for a heat engine. One is the hot reservoir or the source, which is at a temperature T1, which is at a high temperature. It is at a high temperature, so it is called the hot reservoir. Then we are having a working substance. Then the third component is the cold reservoir, or we can say that it is sink at a low temperature. It is a low temperature. It is at a low temperature. And here, next we are going to for the working of the heat engine. First of all, the working substance. Working substance. Working substance is the system which is actually doing the work. For example, in petrol engine, we are having a petrol engine. In petrol engine, air and gasoline mixture. Gasoline, air and gasoline vapor, which act as a working substance. Gasoline means petrol. Gasoline means petrol vapors, which is the fuel, or we can say that the fuel vapor. The fuel vapor is doing the work in the petrol engine. And in the case of diesel engine, diesel vapor is the working substance. In case of steam engine, steam acts as the working substance. That means working substance is the system which is actually doing the work W. The work done by the working substance is denoted by the letter W. Now, then the next process is, consider the figure. In the figure, we are having a Q1 amount of energy. We are having a Q1 amount of energy. It is heat energy. Here, Q1 is the amount of heat energy. It's the amount of heat energy absorbed by the system, by the working substance. It is the heat energy absorbed by the working substance to do the work W. And after doing the work, and then the working substance do some work, working some substances do some work with the use of the amount of energy absorbed from the hot reservoir, which is given as W. Then the remaining amount of energy which is not used to convert work is released, which is defined as the amount of energy released to the zinc. In the figure, we are having a zinc at T2 temperature, and working substance is higher than the temperature of the working substance is greater than that of zinc. So the remaining energy which is do not used for converting work is released to the zinc. The amount of energy released to the zinc or cold reservoir Okay, this is the process. This is the one cycle of process. It is a general case. We are having the general processes discussed here. That means to find the efficiency. The efficiency means the performance of the heat engine can be defined by the letter eta. Eta is called the efficiency. It is pronounced eta. That is, eta is equal to the efficiency. That is, we are giving Q1 amount of energy to the system, and out of that W is the work done. Okay, then W can be represented as the energy absorbed minus energy released. Q1 is greater than, Q1 is the amount of energy absorbed, which is always greater than released. So on simplifying this, we get Q1 1 minus Q2 by Q1, 1 minus Q2 by Q1, or we can say that eta is equal to, since energy is directly proportional to the temperature, we can say that 1 minus T2 by T1. This is the expression for the efficiency of the heat engine. And from this equation, if consider the case if Q1 is Q1 or Q2 is equal to 0, Q2 is equal to 0, we are having eta is equal to 1. That is, we are having Q1 minus Q2 divided by Q1. Then we get Q1 by Q1, which is equal to 1. That means eta is equal to 100% efficiency. That means there is no loss, which means no loss of, which means that no loss of energy in the system, which is not an ideal case, which is not possible. Since we know that some amount of energy will be dissipated in the form of radiation and through conduction, radiation, convection, etc. So here is the heat engine. Heat engine is the device which converts heat into work in a cyclic process. Here, working substance is the system. For different engines, different working substances are there, and here is a cyclic process. First of all, Q1 amount of energy is absorbed by the system, then work W is done, then Q2 amount is released to the reservoir or cold reservoir or zinc. The efficiency is given by eta is equal to Q1 upon W, and we get eta is equal to 1 minus T1 minus T2 or 1 minus Q2 by Q1. And if Q2 amount of energy is 0, that is we get 100% efficiency, which is not possible in the practical cases. Okay, now the next topic is the types of heat engines. The types of heat engine. We are having two types of heat engines. They are, first one is external combustion. External combustion engine, and the next one is internal combustion engine. There are two types of heat engines, internal combustion engine and external combustion engine. For example, here our steam engine is an example of external combustion engine. Here the heat is produced by burning fuel in a chamber outside the main body. Here the fuel is burned. The fuel is burned outside the main body, and then the energy is passed to the system. We know that steam engine, here the coal or diesel is burned outside the engine, and then the energy is used for the running of the piston. And this is a case of external combustion, means the fuel is burned outside the main body. Example is steam engine. And for the internal combustion engine, for example, the petrol engine, the diesel engine, diesel engine. Here the working substance is inside the engine, or we can say that heat energy is produced by burning fuel inside the main body. Here is the difference between internal and external combustion engine. Okay, now we are going to discuss the refrigerator, the working of refrigerator. Refrigerator is the reverse heat engine. It is the reverse heat engine. And consider the figure. This is having our working substance, substance, and this is having source 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 of heat energy, and here we are having sink is having sink at temperature 2 T2. Here reverse means we are taking Q2 amount of energy from the zinc, and here is work done on the system, and heat energy is Q1 amount of energy is released to the source. That means for the case of fridge, our household fridge, consider the case. This is our fridge. This is our fridge. The zinc is the fridge. That is means cold reservoir. It is called a cold reservoir. We are taking the amount Q2 from the inside of the fridge, and we are having some pump or the engine or the substance. Then we are connecting it to the electricity. Here we are giving the electricity, and with the use of this, we are giving to the environment or surroundings, the Q1 amount of energy is released to the. This is the general case of working of a refrigerator. Here the work done on the system. Here we are work done on the system. That means that is why it is called the reverse heat engine. Work done on the system, and we are passing or release. We are absorbing Q2 amount from the inside of the fridge. This is a fridge refrigerator. Then we are giving Q1 to the amount. That means it is in cold state always. This is the working of refrigerator. Now going for the efficiency. Going for the efficiency and going for the efficiency, eta is equal to, here we are having Q2 amount of energy extracted from the system, and work done is W. On giving work W, we are extracting Q2 amount of energy from the zinc. So we get Q2 divided by work done is Q1 minus Q2. This is the performance. Here it is not eta, it is beta. It is beta. Coefficient of performance. This efficiency is also called coefficient of performance. Coefficient of performance. Okay. The problems regarding this topic is done on the next video. Okay, thank you.